Whoever is going to join us will join us along the way. Sindio, Monica?
Ni sawa, teacher.
Okay, so were you in the morning lesson today?
Yes, Nima.
Yes. So good. So we'll just continue from where we left off in the morning. Now remember we talked about factors affecting enzyme controlled reactions. And the last factor we discussed was enzyme inhibitors, where we said that enzymes function can be affected by substances which we call inhibitors. And we said that inhibitors can be divided into two. That is the competitive and non-competitive. Competitive means they are competing. Non-competitive means there's no competition. Now, in competitive inhibitors, we said that the inhibitors are going to have the shape of the substrate. Therefore, they will be competing with the substrate for the enzyme. And we said in non-competitive, you find that the inhibitors are going to change the shape of the active site of an enzyme. And this one affects the way the enzyme and the substrate combines or connects at the active site. And therefore, there will be no breakdown or there will be no catalyzation of the process of breaking down of whichever food substrate. And we say this is a mechanism that the poisons usually use, where when they get into the body cells, they alter the shape of the enzymes, inhibiting any process from taking place, metabolic process from taking place in the body. So let us talk about something different. I want us to talk about other factors. Now the remaining factors are cofactors, and we will see what is a cofactor and coenzymes. So we have cofactors and coenzymes as being the other factor, being the other factor that influences enzyme activity. Now, we have a cofactor and we have a coenzyme. Now, cofactors are non-protein substances that activate enzymes, hence increases the rate of enzymes activity. So cofactors activate enzymes. They do not get used in the process, they just activate. Like for example, if you were to talk about something like metallic ions, magnesium, kuna zinc, kuna copper ions. So in presence of those ions, enzymes are going to function better. Now, as we're going to see in Form 2, when we'll be talking about the process of blood clotting, we're going to see how some of the metal ions are used to speed up the processes in the body. So therefore, tumesema, cofactors actually, they activate the enzyme. So if an enzyme was not active, it gets activated by a cofactor. And of course, we've said examples are metal ions. Then we also have coenzymes. Now, coenzymes are organic cofactors that activate enzymes, hence increase the role of enzyme activities. Okay, so now cofactors and coenzymes are required in small quantities. They are required in small quantities. So cofactors tumesema they are non-protein substances that activate the enzymes, while coenzymes actually are organic cofactors that activate enzymes. So difference hapa ni nini ya cofactor na coenzyme? Difference ni cofactors are non-protein, they are inorganic, they are metallic ions, while coenzymes are organic factors which activate and increases the rate of enzyme activity. For example, we have vitamins. Like for example, in the process of blood clotting, the enzyme the vitamin that is responsible for speeding up the process of blood clotting inaitangwa vitamin K. So you'll find that there are some activities, metabolic activities, which when they take place in the body, they take place well in presence of cofactors or coenzymes. So in an exam, if they ask you to give the difference between cofactors and coenzymes, you'll say that cofactors are non-protein metallic substances, while coenzymes are organic cofactors that activate or increase the rate of enzyme activity. So those are some of the factors that affect or influence enzyme activity. And in an exam, you can get a question asking you to discuss either of those factors, or they can give you a graph and they expect you to discuss or to explain. Like for example, let's do several study questions on the same, and then we can proceed to something else. So now there's this question which is being shown there, study question. The figure below shows the rate of enzyme action in relation to changes in temperature. Study it and answer the questions that follow. So in this figure, as you can see, we have point Q, we have point R, we have point S, and we have point T and point U. So if we were to discuss this process, what is happening at these different points, you can see from point Q to point R, the rate of reaction is increasing. And then at point S, that is the highest point of the reaction. And then of course from R to T, and then from T to U, there's a decrease. There's a decrease in the rate of enzyme activity. Now when you study the graph, you will see on one side we have temperature, on the other side we have rate of enzyme activity. So therefore it means we are discussing or we are looking at effects of temperature on enzyme activity. And remember the points which we made when you're discussing temperature as a factor that affects or influences enzyme activity. We said that enzymes are very inactive when the temperatures are low, meaning they're not going to perform any activity. When the temperatures are at the right range, then the rate of reaction is the highest, and then the right range in temperature, we said it is optimum temperature. Sasa ukiangalia hii graph, hii point S hapa, that is what we call the optimum temperature, because that's where we have the highest rate of enzyme activity. Then from there, we also said that extreme temperatures above 40 degrees Celsius, they denature enzymes. And once the enzymes have been denatured, it's the same as being killed. And when they get killed, of course, they are not going to function in any way. So let's see what the question is asking. So question 1, explain giving reasons the rate of enzyme action between Q and R. Between Q and R. So in our graph, we have point Q and R. What is happening at point Q and R? Between point Q and R, what is happening?
The rate of enzyme increases.
The rate of enzyme action or the rate of enzyme activity
Increases.
increases. Yeah, good. So why is it that the rate of enzyme activity is increasing?
It is increasing with the increase of temperature.
Yes.
Suitable
Good.
temperature.
Yes, it is increasing because the temperature is increasing. That's very good. From R to T, what is happening?
R to T. Yeah.
Hapa kuna point S.
The enzyme. Kwa R to S ama R to T?
R to T, S iko hapo katikati. R to T.
From R to S, I think the rate of enzymes equal at, the temperature is at optimal.
Hence the rate of enzyme activity is at the highest.
Yes, but S to T, yeah, the temperature as it increases, it denatures the enzymes, the rate of activity, the rate of enzyme activity
is decreasing, isn't it? So
yes.
at point T, at point 2 una expect temperature ikuwe kiasi gani at point T?
Above 40.
Above 40 something kwenda juu, isn't it? And then at from point T to U? What has happened to the reaction from point T to U?
It decreases.
Yes, the rate of enzyme activity is decreasing because there's an excessive increase in temperature, isn't it?
Yes.
Good. So at point A to S, at S there is maximum rate of enzyme reaction because it's at optimum temperature. From point T to U, there's a drastic drop in the rate of reaction enzyme because very high temperatures denatures or destroys enzymes. Higher. Other than factors being investigated above, that is the temperature, state 3 other factors that affect the rate of enzyme activity. So other than temperature, which other factors affect the rate of enzyme activity?
Tumesema other than temperature.
Yes, other than temperature.
We have
Uh-huh.
pH. We have enzyme concentration. Then we have substrate concentration.
And the cofactors and
Na
coenzymes and inhibitors.
Yes. Hizo zimetufundisha saa hii hizo enzyme cofactor na enzyme coenzyme.
Coenzymes, eh? Higher.
Hiyo enzyme inhibitors, yes.
Good. State the collective name for the enzymes that work on carbohydrates.
Enzymes that work on
carbohydrates. Based on naming, based on the food substrate.
Is this one teacher? It's written there. Carbohydrates.
Yes, carbohydrates. We can name an enzyme based on the food substrate it breaks down, isn't it? So therefore, kama ni carbohydrates inakuwa carbohydrates by adding ASES at the end, isn't it? Proteins?
Proteins.
Lipids?
Lipase.
And that marks the end of nutrition in plants. How did you find that subtopic, nutrition in plants?
Not bad.
Not bad, isn't it?
Yes.
So we can be able to answer questions which gets tested from that area. That is good. That is good to hear. So do we do some few questions on nutrition in plants ama tuendelee nutrition in animals?
Sister, I'm okay with any, but I think to proceed, since tulifanya some questions,
we proceed, isn't it?
Maybe kuna
basi haina.
So naona sijui kama Domi amejoin.
Naona ni kama ametujoin.
Amin.
When you are away, we discussed the last factor affecting enzyme activity na tukafanya maswali mbili hivi. So I think we can proceed to nutrition in animals. Domitila, how did you find the subtopic nutrition in plants generally?
It is okay. It is, as in, for me, I have the content now. Yeah.
So
and
we
I
are
think,
good.
I think the questions that you have done with Monica, we did them in the morning. Yeah.
So then we proceed to nutrition in animals, isn't it?
But teacher,
yes, that's okay.
Yes.
Teacher, before you proceed, graph, did they look different? Because somehow kuna zingine yenye tulikuwa tunaangalia morning, it was like nasema hizo graph zenye tunafanya as in kama like ya temperature ama ya substrate concentration ama ya enzyme concentration ni must zikuwe zina curve ama they will differ at times.
They will differ kwa sababu ile ya temperature inapanda, ikifika optimum temperature sasa zina denature enzyme, so ina drop, inaacha, unaona. Lakini ile ingine like ya enzyme concentration na substrate concentration haiwezi drop kwa sababu kitu moja itakuwa inaongezeka, unaona, like food substrate itakuwa inaongezeka, so itapanda alafu mahali ikuwe constant, hakuna kudrop. So they'll be very different. Kama ni ile ya pH utapata itaenda ikipanda, ikifika optimum alafu pH change kabisa, enzymes zinakuwa denatured. Zikikuwa denatured, reaction ina stop, so inaanza kudrop. So kudrop inamaanisha enzymes zimekufa ama zimekuwa denatured. So kama si factor, kama kuna factor yenye ina denature enzymes kama extreme temperature or extreme change in pH, lazima kunakuwa na drop. Lakini kikuwa ni factor ingine yote, hakutakuwa na drop. What will happen ni ati hiyo graph itaanza kukua stable, itaenda ikiwa straight sasa, on a straight line.
Yeah.
Sababu enzymes hazijakufa.
Sasa nilikuwa nimeona kama hiyo yenye nasema sahihi. Yes.
Iko straight kwa sababu enzymes hazijakufa, ni venye ni kidogo, so zinaendelea tu kufanya kazi venye ziko juu zimetosha, unaona. Ni kama tuseme for example let me use an example of something like a party. Tuko kwa sherehe, so we have a party and we have 5 people in a party, and after every 2 minutes ama after every 10 minutes hawa watu wanakula chapo moja. So ni kumaanisha after every 10 minutes kutakuwa kunakuliwa chapo ngapi? Chapo 5 peke yake juu hawa watu ni 5, si ndio? Ukiweza ongeza watu wengine 5, si watakuwa sasa watu 10, na after every 10 minutes kila mtu kwa hiyo nyumba anakula chapo moja. So chapo zitaongezeka zenye zinakuliwa zitoke 5 ziende 10. Ukiongezea watu wengine 5, sasa chapo zenye zitakuwa tutakuliwa after 10 minutes zinaanza kuongezeka, zinakuwa 15. So ukiongezea watu wengine wakuwe 20, chapo zenye zinakuliwa after every 10 minutes zitaongezeka zikuwe 20. So from there ukiweza kosa kuongeza watu, chapo zenye zitakuliwa sasa continuously hadi hiyo siku ishe zitakuwa after every 10 minutes 20, every 10 minutes 20. Hata ukiweza leta watu 50 wapike chapati, bado wale wenye wanakula hawata change, watabaki kukula moja. So hata ukipika chapo 50 every 10 minutes, zenye zinakuliwa ni 20 peke yake, so that is zinakuwa extra, unaona. So in this case food substrate ndio, enzymes ndio watu wenye wanakula, food substrate ndio chapati sasa. So hakutakuwa na drop ati tuseme wanakula, lakini sasa tuseme for example hawa watu wenye 20 wako kwa hiyo room mmoja akuje na sindano ya kudunga watu ya usingizi, alafu watu kama 5 wadungwe sindano ya usingizi. What will happen to the amount of chapati consumed every 10 minutes?
Zitabaki hivyo ama zitapungua?
Azinasema every minute watu 20 wanakula chapo moja every 10 minutes. Sinikumaanisha watakula chapo 20. After some time watu kwa hiyo room watu 5 out of the 20 wadungwe sindano ya kulala. So wenye watabaki soba ni 15, si ndio?
15,
what will happen? So chapo zenye zinakuliwa after 10 minutes zitakuwa ngapi? 15. So unaona zimeanza kudrop. So not unless sasa hawa watu wakiweza kuwa ndio enzymes, not unless kwa cell enzyme imekuwa killed, reaction rate huwa ina remain constant. Ndio maana line inaenda ikiwa straight continuously. Lakini zile factors zenye zina destroy enzymes ndizo zinafanya sasa the rate of reaction inaanza kudrop, kwa sababu zile enzymes zilikuwa kwa cells zimeanza kukufa. So rate of reaction inaanza kufanya nini? Kudrop. That is an example of what is happening. Yeah. Okay. Now, between nutrition in plants and animals, personally I find nutrition in animals to be very interesting. Probably because I'm an animal maybe, but to be honest I find it interesting and easier. So kama ulielewa transport in plants, sasa hata hii itakuwa even easier. So can we dive right into nutrition in animals? Now, what is the difference between nutrition in animals and nutrition in plants? One main difference between nutrition in animals and nutrition in plants. Anyone who has an idea? Like if you compared an animal and a plant in terms of nutrition, what is the main difference?
I think in plants, plants depend on, as in, plants, they make their own food, while animals depend on ready-made food.
Very good. That is the main difference actually. Animals depend on ready-made food. Plants make their own food. So therefore, those organisms that make their own food, we refer to them as autotrophs. Autotrophs. So therefore, the type of the mode of nutrition in plants is autotropism. And then we have heterotrophs. Heterotrophs are those organisms that depend on already made food like us. See, we are heterotrophs because we do not make our own food. We depend on already made food. So we are heterotrophs. The mode of nutrition is heterotropism. Okay, so wewe ni heterotroph and you feed through heterotropism. You obtain nutrients through heterotropism. Remember tulisema nutrition is a process through which living organisms acquire and utilize, or they obtain and utilize. So how do you acquire food? You acquire food from already made from plants which have already made their own food, or from animals products, and then you utilize that those nutrients in your body. So heterotropism involves organisms depending on already made food. Then we have types of heterotrophs. Types of those organisms that depend on already made food. So number one, we have herbivores. Now, do you know what are herbivores? Herbivores are those organisms that feed on plant materials. For example, we have cows, goats, sheep, and grasshoppers. How what any herbivores? Now, herbivores, they depend on green plants, or they depend on plant materials for their food. Then we have carnivores. Now, carnivores, they feed on flesh. They feed on meat. For example, lions, dogs, hyenas, eagles. So, when it comes to carnivores, they don't feed on vegetables. So, it is very wrong to give your dog or your cat some vegetables. Unapewa mahali nilienda nikapata mbwa anapewa githeri ya kule. That is very wrong because that animal is a carnivore. It is not an omnivore. Then we have omnivores. Omnivores ni kama sisi sasa. Those organisms that feed on both flesh and also feed on vegetables. Like for example, we have us human beings and we have pigs. So it can feed on flesh, and another time it can feed on vegetables. That is what we call an omnivore. Then we have saprophytes. Now, saprophytes are organisms that feed on dead, decaying matter, leading to decomposition. Organisms that feed on dead, decaying matter. Like, for example, when a plant has been cut, or a plant material has been cut, that plant material is going to start decomposing because we have some saprophytes feeding on it. And when saprophytes feed on any organism, they cause decomposition. So the very most important function of saprophytes is to cause decomposition. That is the very most importance of saprophytes. So bacteria are saprophytes, fungus are saprophytes. Then we have parasites. Parasites, they live on other organisms called the hosts without benefiting them. So we're saying that saprophytes feed on dead, decaying organisms. Parasites, they feed on, they depend on other organisms without benefiting them. Like for example, we have cattle and ticks. So cattle is the host, and then the ticks are the parasites. I think those ones are pretty much straightforward. So no, a lot of explanation is needed. So types of heterotropism or modes of heterotropism. Types of heterotropism or modes of heterotropism. Now, when you talk about types, we are basically asking ourselves, tulisema heterotropism is a process through which organisms feed on already depend on already made food. So how many types of heterotropism are there? Number one, we have holozoic nutrition. Now hii holozoic basically means it is a type of nutrition where organisms depend on solid food. They take in solid food substances. Like for example, sisi human beings or most of the animals, we are holozoic, meaning we feed on solid food materials. So any organism that feeds on solid food materials, it is a holozoic organism, and therefore it shows holozoic nutrition. A very good example of organisms that have holozoic mode of nutrition is any animal that you know, be it a dog, be it a human being, be it pigs, be it chicken, be it sheep, because they are feeding on solid food. The food is in solid form. Then we say that that organism is a holozoic nutrition mode of nutrition, and mostly they are the ones that now include herbivores, omnivores, and carnivores. So herbivores, omnivores, and carnivores, they fall under holozoic nutrition because they feed on solid food substances. Good. Then we have saprophytism, just like we discussed, tukasema, saprophytism is a mode of nutrition where an organism will obtain nutrients from dead decaying organic matter, causing decomposition. So if, for example, a plant or an animal dies, the reason why that plant or that animal is going to decompose is because it is going to be broken down by organisms known as saprophytes, and saprophytes are basically fungi and bacteria. So therefore they cause decomposition. Then we have parasitism. Parasitism is easy. This is where one organism depends on the other. It's a mode of nutrition where one organism, which is the parasite, depends on the other, which is the host, without benefiting it. So like for example, ng'ombe na ticks. So the cow here, or the bull, or what we call cattle in general, they will be giving the tick food, and then these ticks will never benefit the host in any way. So therefore we refer to that as parasitism, a parasite. So a parasite is any organism that depends on the host without benefiting it in any way. We have very many examples of parasites. We have like ticks, we have lice, we have roundworms, we have tapeworms zenye ziko ndani ya mwili. So all those ones are examples of parasites. And therefore the mode of feeding where organisms feed depend on the other without benefiting them is known as parasitism. Then we have symbiosis. This is the best mode of nutrition because in symbiosis you're going to find that both organisms are going to be beneficiary to each other. So this is an association where two organisms live together and they mutually benefit each other. For example, we have Rhizobium bacteria and leguminous plants. So Rhizobium bacteria and leguminous plants. Now, leguminous plants are those plants which fix nitrogen in the soil. So most of the leguminous plants provide us with proteins. Like for example, kuna maharagwe, kuna kunde, kuna peas. So all those plants, they are leguminous because they supply us with proteins, and also they play a very important role in the soil, which is fixing nitrogen in the soil. Now nitrogen is very important in the soil. Like for example, nitrogen is responsible for vegetative growth. Ukiweza enda upite mahali upate kuna mahali umeona sukuma kubwa na watu wanapiga dawa hiyo sukuma, usually wanakuanga wakipiga nitrogen. I'm sure umewahi sikia mahali wakisema hizi chakula tunafaa kuzipiga dawa ya foliar. Foliar ni dawa yenye iko na nitrogen mingi sana yenye itafanya the vegetative growth, ama itafanya majani ichomoke haraka, itafanya fruits zitoke kwa wingi, itafanya mmea ikue haraka, kwa sababu nitrogen is responsible for growth of plants. Okay, so therefore leguminous plants, they require rhizobium bacteria to fix nitrogen in the soil, and then of course the rhizobium bacteria will benefit from the food from the leguminous plants. So these two organisms are benefiting each other. So leguminous plants are getting nitrogen fixed in the soil for their consumption, and in turn the leguminous crops are going to actually they are going to provide the nutrients to the rhizobium bacteria. So symbiosis is any mode of nutrition or association where two organisms are benefiting each other mutually. So there's a very big difference between parasitism and symbiosis, in the sense that parasitism, only one organism benefits. Then we have phagocytosis. So this is a type of nutrition where single-celled organisms, e.g. amoeba and some white blood cells, feed on solid food materials. Actually, phagocytosis means kufungia ndani. Like if you look at this structure here, we have the food inside the organism, and then the organism is going to fuse up and like swallow the food substance. So at the end, you're going to have something like this. So that is how food is fed on by some unicellular organisms. Now, unicellular organisms are organisms which are made of one cell. Those are the unicellular organisms. So they feed through phagocytosis. Zinafungua ni kama one part of the body, and then they put in the food substance and they enclose it inside and digest it. That is the different types of nutrition, of course, in heterotropism. So I repeat: holozoic nutrition, saprophytic nutrition, phagocytosis, parasitism, and symbiosis. Now, before we discuss how animals feed, let us see what animals use for feeding. And of course, animals use the mouth for feeding. Like for example, wewe, chakula chote kenye unakula ama unakunywa kinapitia kwa mdomo. So therefore, we have something known as dentation and dental formula. The question is, what is the difference between dentation and dental formula? Now, I remember when I was in high school, there was a teacher of us that was teaching us chemistry. Every time the teacher would find you smiling, she would ask you, what is so funny that you had to show you a dental formula? So therefore, from that, you have an idea of what a dental formula is. So dentation, we begin by dentation. Dentation, it refers to the description of the types and the arrangement and specialization of teeth in animals. So dentation iko na description of the types, how many types are there, how are they arranged, and how are they specialized to their function. Like for example, we know in human beings we have incisors teeth, iko hapa mbele yenye tunakata nayo vitu, they is used for cutting food. Then we have the canines. Canines ni hizi nne, kuna mbili juu na kuna mbili chini. They are very sharp. The function of canines is to slice. It is used mostly to slice food. And then of course we have the molars and the premolars. The function of the premolars and molars is to grind or to break down food. So therefore, that classification, specialization, and actually the arrangement of the different types of teeth is what we call dentation. So your dentation has incisors, canines, molars, and premolars. Then we have types of dentation. How many types of dentations are there? How many types of the teeth are there? Now, dentations ziko mara mbili. Tuko na homodont dentation na kuna heterodont dentation. Homo means similar, it means the same. Now, there are some organisms that have the same number of teeth, the same shape, the same size. Like, for example, in shark. I'm sure you've ever seen a shark or a video of a shark, of course, or a photo. I'm sure you have ever also noted that meno yote ya shark inatoshana in size, inatoshana in shape, na inatoshana even in modification. So inafanana size, shape, the same in number. So ukichukua shark moja ukompare na ingine zinafanana. So that's what we call homodont dentation. So this is a type of dentation where organisms have all teeth with similar shape and size. For example, in fish, like for example shark, and then of course we have frogs. Yes, there are some frogs which have teeth, and crocodiles. So if you are to take the jaw of a crocodile, all the teeth in a crocodile have the same shape and size. So therefore, homodont dentation is a type of dentation where organisms have similar shape and size of teeth. Then we have the other one which is heterodont dentation. If you remember very well, sijakutaja mahali nikisema kuhusu homodont because kuongea ukweli meno yako haifanani in shape na hata haitoshani in size na hata haiko the same in structure. So therefore, we organisms that have different types of teeth that actually are of different size, we fall under heterodont dentation. So in heterodont dentation, you'll find that the teeth are of different shape and size. Like for example, we have the incisors, we have the canines, and we have the molars and the premolars. Those teeth are not the same. They don't even perform the same function. They're not even specialized to perform the same function. So each type of teeth has a different function. So therefore, we fall under heterodont dentation. So we have homodont dentation. These are dentation in which organisms have similar size and shape of teeth. And then of course we have heterodont dentation. Now, what are the advantages of heterodont and homodont dentation? Of course, you'll find heterodont is more advantageous compared to homodont dentation kwa sababu each and every type of teeth is actually, each and every type of a tooth in homodonts is specialized to perform a specific function. And like when all the teeth are the same, therefore you find that the organism is not able to feed well because the teeth are not going to do a good job. But wewe ukiwa na ile ya kukata, uko na ya kutea na uko na ya kuchew. So therefore you're going to have an advantage compared to homodont organisms. So that is dentation. It is the description of the types, arrangements, and specialization of the teeth. Then we have dental formula. Remember the heading is dentation and dental formula. So you're done with dentation. Let us talk about dental formula. So dental formula basically describes the type, the number, and the position of teeth in a jaw. So in a jaw of an organism, where do we find the incisors? Where do we find the canines? And how many are they? So therefore, when you talk about the dental formula, it is basically a description of the type of teeth, where they are found, and the function that they carry out. So that is dental formula. So therefore, when you're calculating the dental formula, there's an experiment that I want us to do. And the good thing is that we are going to be our resource persons today. So now I want you to use your tongue and feel the number of teeth in your mouth. Just feel them. And I'm sure as you're feeling the teeth, of course, if you have all the teeth, you're going to find that you don't have the same type. Kuna watu wako na meno, even the number is not the same. Kuna watu hata walishang'oa meno yao. Okay, but if you have all the teeth in your mouth, then you're going to realize something. You're going to realize that you have different types of teeth. Now, I want us to learn how to calculate the dental formula. Now, Incisors ziko mbele ama ziko nyuma? Incisors ni hizi zenye ziko wedge shaped. So hizi zenye ziko hapa mbele. How many incisors do you have on the upper jaw? Anyone? How many incisors do you have on the upper jaw?
2.
You have 2 incisors. Hizi za kwanza, hizi zenye ukicheka ukismile zinaonekana. How many are they on the upper jaw?
The sharp ones, teacher, ama tu hizi za mbele kabisa.
Hizi za mbele kabisa zinakaa wedge shaped.
Yeah, there are 2, teacher.
Like ukismile.
There are 4.
There are 4, isn't it? Na side ya chini ni ngapi?
Pia 4.
Yes, they are also 4. However, when you're writing the dental formula of an organism, hauandikangi zote at 8/8. Juu tukiandika dental formula tunaangalianga the number of teeth on the upper jaw and the lower jaw. Like for example, let me show you an example somewhere. We have this, the dental formula of a herbivore. Unaona wameandika I 0/3, C 0/1, PM 3/2, and M 3/3. Now, you see what's the difference between writing? So kama sisi tukiandika yetu, I want to show you the dental formula of an omnivore, Sisi. The dental formula of an omnivore, ndio hii. So we have 2 incisors over 2 incisors. Is that true? Do you have 2 incisors on the upper jaw? Hii ikiandikwa in fraction, hii ya juu inakuanga the upper jaw na hii ya chini inakuanga the lower jaw. So ukiangalia, ukiguza meno yako na ulimi, do you have 2 incisors on the upper jaw kweli?
4.
We have 4, isn't it? But ukiangalia vizuri hapo utapata wameandika 2. Same with on the lower jaw. Now let us check the next ones to the incisors, the canines. Hizi zenye ziko sharp kabisa. How many canines do you have on the upper jaw?
2.
What about on the lower jaw?
2 also.
2 also. But ukiangalia hapa wameandika C of course is for canine, wameandika moja juu na moja chini. Hataenda kwa premolar. Premolar should be 4/4, but hapa wameandika 2/2. Molar should be 6/6, then we have 3/3. So ukiangalia ni kama wameweka nusu. Unajua ni kwa nini huwa wanaweka nusu? Now, when you're counting the number of teeth in any organism, you do not consider the whole jaw, you consider half the jaw. Unaona hizi incisors zako mbili penye we have 4. But ukiangalia vizuri utaona, especially kuna watu hata wanakuwa na mwanya, unapata 2 incisors ziko on the left and the other 2 incisors are on the right. Si kuna hiyo difference yenye unapata unaweza gawanisha mara mbili. Now in that case, when we are counting or when you are writing the dental formula, we count half of the jaw. Hatuchukuangi yote. Like for example, ukihesabu meno yako ya juu ya incisors kwa hapa jaw, utasikia it is 4. Now instead of using 4, we use 2 because we are considering the half of the jaw. So kuna mbili nusu. Then ukienda hapo next utapata kuna incisor moja juu, canine moja tu na canine moja chini. Then ukisonga hapo mbele. So when you're counting the dental formula of an organism, or when you're writing the dental formula of an organism, we usually do consider half of the jaw. Ndio maana ukiangalia hiyo dental formula inakaa ni imeandikwa in half. Is that okay?
Okay.
Now a question comes up. If you are told to count the number of teeth in an organism such as an omnivore, how will you count? Because tumesema we consider half the jaw, tunakujanga tunasema 2. So first of all, we actually usually add the numerators and then we add with the denominators. So tukiongeza numerators hapa kwa hii dental formula iko hapa ina display, the one that I'm displaying, this one here. Ukiangalia vizuri utaona that the dental formula is I of course is for incisor, and then we have C for canines, then we have PM for premolars and M for molars. So ukitaka kuhesabu the total number of teeth in an organism, huwa unatumia nini? Huwa una add numerators kwanza, alafu una add denominators, and then you multiply by 2. Like for example, 2 incisors plus 1 canine, that is 3, plus 2 premolars, that is 5, and then plus 3 molars, that is 8. So we have 2, 3, 4, 5, 6, 7, 8. So tutakuwa na 8 on the upper jaw. Then on the lower jaw tuko na 2 plus 1 plus 2 plus 3, it will be another 8. Okay, so 8 on the upper jaw plus 8 on the lower jaw, we call that 16. Alafu sasa hii 16 we multiply by 2 kwa sababu tulihesabu half the jaw. So usually if you're told to write the dental formula or calculate the number of teeth in an organism, that is the criteria you use. You use all the numerators, you add them, and then you add them to the denominators and multiply by 2. Okay, now so you have learned something today. You have learned, but when you are counting or when you are counting the number of teeth in an organism using the dental formula, we count half of the jaw. So unaenda hapo katikati ya meno yako ya incisors, ingine inakuwa nusu side moja na ingine inakuwa hiyo nusu side nyingine. So that is how we calculate the number of teeth in an organism using the dental formula. Tumeelewa ama tumeyumba kidogo?
Tuko sawa.
Tuko sawa, very good. So let's go back to what we were doing. We were still talking about modes of nutrition and holozoic ama heterotropism, where we have said we have holozoic, we have symbiosis, we have parasitism, we have phagocytosis, etc. Now, let us talk about types of teeth. Now, we have different types of teeth. We have incisors, we have canines, we have premolars, and we have molars. How many types of teeth do we have? We have 1, 2, 3, 4. 4 types of teeth. That is for omnivores, sisi, binadamu. So we usually do have the incisors. Those ones are the outermost. Hiyo ndio yenye ukismile watu wanaona. Then next to the incisors is canines. Now the shape of a canine is that it is a bit sharp. And then we have premolars. Now premolars are primarily destined for chewing. That is premolars, and also molars. Now let us look at the different types of teeth. Incisors. So with the diagram here, that is how an incisor looks like. And an incisor is located at the front of the jaw. So iko hapa mbele kwa meno, at the front of the jaw. Adaptations of the incisors. Ukiangalia vizuri hii incisor, utaona inakaa chisel shaped. So it is chisel shaped, and the reason why it is chisel shaped is so that it can actually be able to bite. It can bite on food. Then we have incisors have one root to support them in the jaw. Ukiangalia vizuri utaona incisor kama kwa hii diagram, it has a single root. Haina mizizi mingi, just one single root. That explains the reason why mtu anang'oka meno ya mbele sana, kwa sababu haina support mingi. It is only supported with one root. Okay, good. Then we have canines. Canines are a bit different from the incisors because they have a very pointed edge. And then just like the incisors, they are supported by one root. So we are saying that the adaptations of canines is that they are sharp pointed and they are made up of one root. So that is the canines for you, and that's how it looks like. Then we have premolars. Premolars. Pre means comes before molars. So they are located after the canines towards the back of the jaw. They are located after the canines towards the back of the jaw. So premolars zinakuja just next from the incisor. So if you can use your, canine, sorry. If you can use your tongue, I want you to feel the incisors. So mi nataka uzungushe your tongue in your mouth, feel the incisors, and then move to feel the canines. From the canine, I also want you to move so that you can feel the premolars. Now, the main difference between premolars and the incisors and the canines is that premolars have two roots. They don't have a single root like the incisors and canines. No, premolars have two roots which provide a firm support. Ndio maana kung'oa meno kama hiyo ya premolars inakuwa ngumu kwa sababu it is supported by two roots, unlike the incisors and the canines. And then of course they have a broad-ridged crown, and the reason why the crown is broad-ridged is so that it can provide a surface for chewing of food. So premolars are primarily used for chewing. Now we have another type of teeth, which is the molars, and the last one. Now the difference between premolars and molars is molars are located at the back, at the extreme end of the jaw, and then they are made up of three roots. Molars are made of three roots. So only incisors and canines are made up of one root or supported by one root. But for the molars, they are going to have three roots, and the premolars are going to have two roots. Hence, they are well supported. Na tumesema function ya molars na premolars is basically to chew food, nothing else. Now that we have learned the different types of teeth, and we have learned about different types of organisms that depend on already made food, where we concluded that those organisms include carnivores, herbivores, and omnivores, I think it is only right if you look at the herbivore dentation. How does a herbivore look like? What are some of the parts that you can see of a herbivore when you look at herbivorous animal? First of all, we have to agree on which is a herbivorous animal. A herbivorous animal is an animal that feeds on either vegetation or it feeds on grass or even herbs and shrubs. Okay, so it can feed on grass, huku chini tu inakula grass, alafu inaweza feed on twigs of trees like the giraffes. The giraffes are very tall, so they feed on twigs of trees. Huko juu ya mti inakula hawa majani yenye inatokea hapo. So it is also a herbivore. So long as it is feeding on plants, it is a herbivore. Now, how are these organisms modified to their function, ama how they adapted? Na ukiangalia dental formula ya herbivores utaona on the upper jaw, I stands for incisors. On the upper jaw, there is 0 incisors. On the upper jaw, there is 0 premolars. However, on the lower jaw, we have 3 incisors and we have 1 canine. When it comes to premolar, both the upper jaw and the lower jaw have premolars, where apparently the upper jaw has more, 3, than the molars on the upper jaw, which are 3, and the lower jaw are 3. So all herbivores, if you want to know a herbivore, on the upper jaw hakuna meno. Meno iko on the lower jaw, especially the canines. Yes, the canines and the incisors, they are 0. Okay, now instead of the incisors and the canines, herbivore has a structure known as the horny pad. H-O-R-N-Y-P-A-D, the horny pad. Now the horny pad is very important for livestock, for herbivores, because as grass is being cut when the animal is feeding, huwa inachukua meno ya chini, that is the incisor, inafinyilia kwa horny pad which is on the upper jaw. So hapa kwa upper jaw hakuna meno. It is a structure known as the honey pad. Na hiyo honey pad inasaidia when the animal is feeding, inachukua nyasi, inafinyilia hapo kwa honey pad, alafu inavuta, inakatika. So the honey pad is very, very important for the feeding in herbivorous animals. Again, katikati ya incisor, ya canines na premolar kuko na gap. Katikati ya canine na premolar kuko na gap. Now let me show you this well in a diagram. Now ukiangalia diagram yenye nimeillustrate hapo, utaona hapa kumelabeliwa point J, hapo ndio kuko na incisors na kuko na canines. Na ukiangalia vizuri utaona that jaw is a lower jaw, si ile ya juu. So we have a lower jaw there. Then katikati ya canines and the premolars, katikati ya canines and the premolars and the molars, utapata kuko na gap, na hii gap ndio imeandikwa letter K. Hii gap yenye imeandikwa letter K inaitwa diastema. D-I-A-S-T-E-M-A. D-I-A-S-T-E-M-A, diastema. So hiyo gap inaitwa diastema. Kazi yake ni rahisi, kwa sababu chakula inakuwa chewed by the molars and the premolars. Hizi zimeandikwa L hapo. Chakula yenye inakatwa haifai kuchanganyikana na yenye inakuwa chewed hapo at point L. So usually what happens is to provide a space for turning the food in the mouth and separate the freshly cut grass and the chewed grass, then all herbivores do have a diastema. Ndio kama ng'ombe anakula, ile majani yenye alikuwa amekata akaweka kwa mdomo inakuwa chewed, haitachanganyikana na yenye inakatwa saa hiyo. So therefore the function of a diastema is to allow manipulation of food, or to allow food to be turned in the mouth, and also to make sure that the chewed food does not mix with the freshly cut food. Are we following? Tuko pamoja up to that point?
Yes, mwalimu.
Very good. So good. So therefore, every time we talk about herbivores, there are a few things you should know. Number one, they lack incisors on the upper jaw. Instead, they have a honey pad. And it is in this honey pad that grass is pressed against while feeding. Then, the other advantage is that, the other adaptation of a herbivore is that there is a diastema found in between the canines and the premolars. Katikati ya canines na premolars kuna ka space kako hapo kanaitwa diastema. That function of the diastema tumesema inasaidia nyasi yenye imekatwa isichanganyikane na yenye imechukua chewed. So it prevents mixing of the freshly cut grass and grass which has been already chewed in the mouth. Then the same diastema is going to allow food to be turned slowly in the stomach. So it allows manipulation of food in the mouth. Sorry, not stomach, but in the mouth. So as the livestock is feeding, hiyo diastema ina separate nyasi yenye inakuliwa saa hizo na yenye inaendelea kukua chewed kwa mdomo wa herbivores. Okay, good. Haya, the other adaptation of herbivores is that they lack canines to facilitate sideways movement. Haina canines, especially on the upper jaw. I don't know if you ever checked how sheep or how cattle or how a giraffe feeds. When they are feeding, instead of moving the jaw up and down, their jaws tend to move sideways. So kama ni ng'ombe anakula, unaona the jaws are moving sideways. It's like they are grinding food. So when one jaw is moving to the left, the other one is moving to the right. So that is how the jaws of herbivores move. The reason why they're able to move like that, it's because the herbivores themselves do not have actually canines. So the free movement is because they do not have canines on the upper jaw. Very good. The other adaptation of herbivores is that herbivores, the crowns of the molars and the premolars have a broad surface with cusps and ridges which increase the surface area for grinding. Okay, so unapata sasa the molars and the premolars ziko very broad so that they can be able to chew and grind food. Okay, yes, good. The other adaptation of a herbivore is that the teeth grow continuously throughout the life of the animal to replace the worn out enamel. You see, herbivores are very interesting. The reason why I say they are interesting is because you see that sheep which you see there, like for example, if you have cattle or you have sheep at home or a goat, the teeth of that sheep will never wear out. And if it wears out, it will always be replaced. Unlike CC, the reason why you will not find a cow with a tooth decay or dental caries ama sheep iko na tooth decay, si kwa sababu it feeds on herbs, no. It is because their teeth continually grow throughout. So hii part ya nje ya meno yenye inaitwa enamel, hii part yenye iko hapa ikianza ku wear out because of the chewing, kuna ingine yenye itatengenezwa na ikuje na repair yenye inaisha. Unlike for us human beings or mammals, where if your enamel wears out, it has worn out completely. So therefore you can only have what we call root canal ama maybe ikuwe extracted. But when it comes to herbivores, you'll find that their teeth are going to grow continuously, and as they grow continuously, this allows the teeth to replace the worn out parts of the teeth. So points to take home here: the upper jaw of a herbivore do not have any canines or incisors. Instead there's a honey pad. And then we have the diastema, which is the gap between the lower jaw and the canines and the premolars. And then the other adaptation is that they lack canines on the lower jaw to facilitate side movement of the food. And then of course we have said that their teeth grows continuously so that they can replace the worn out teeth. And then of course we have that the lower incisors have chisel shaped crowns, which will actually be used for cutting vegetation. So out of all those adaptations, you can pick 3 because they are highly examinable. Now, one in which they can test this content, it's like using the study question that I have shown there. The diagram below represents the lower jaw of a mammal. So you have not been told which type of a mammal it is, but you've been told that the diagram represents the lower jaw of a mammal. So the question is, name the mode of nutrition of the mammal whose jaw is shown. Name the mode of nutrition of the mammal whose jaw is shown. So in short, unaulizwa huyo mnyama mwenye unaona jaw yake hapo, which type of nutrition does it show? Does it make its own food? Does it feed on already made food? And when you look at the structure of the jaw, what does it look like? Of course, it looks like it's a herbivore, an animal that feeds on grass or on shrubs. For example, we have sheep, we have cattle, we have goats. They all have the same types of jaws because they feed on the same diet, which is vegetation. Give a reason for your answer in A above. So mbona useme ni herbivorous animal? Of course you can see we have the part labeled K. Na hiyo part labeled K tumesema it is known as the diastema. Na kazi ya diastema is to allow food to be manipulated or turned in the mouth. Unafanya sasa mdomo inaweza kufanya nini? Kugeuza chakula wakati mdomo ama chakula kinakuwa chewed in the mouth. So it has a diastema. The other question, question C, name and give the functions of the toothless gap labeled K. Na tumesema toothless gap labeled K is the diastema. Na tukasema kazi ya diastema is to allow manipulation of food to separate grass which has been chewed and the freshly cut grass. That is the function of the diastema. So the other question, question D, state one structural and one functional difference between the teeth labeled J and the teeth labeled L. So ukiangalia vizuri utaona katikati ya J na L kuna difference kubwa sana. J ni incisor, L ni molar. J ni incisor, L ni molar. Na ukiangalia vizuri hayo meno, hayako located at the same place na haikai kufanya the same function. Incisors kazi yake, hiyo part inaitwa J. The function is actually to cut grass. It is used to cut grass, while in part L, utapata part L, the teeth are modified for grinding or for chewing. So structural difference. Tooth J is narrow and sharper compared to tooth L. And then tooth J has one root, while tooth L has 3 roots. So tooth J tumesema it has 1 root, while we have tooth L which has, of course, more than 1 root. That's the structural difference. Functional ni kuulizwa kazi yenye inafanya. If in an exam you asked about structural difference, structural is basically how is this organism made? How is this structure made? When you look at the structure, what do you see? What can you touch? That is the structural difference. Functional difference is what does it do? Like for example, tunaulizwa kati ya tooth L na tooth J kazi zao ni gani? So ukiangalia vizuri utaona tooth L inatumika kufanya nini? Cutting grass. Okay, so tooth J, sorry. Tooth J is used for cutting grass, and then there is tooth L. And the function of tooth L is basically to chew food. And then the last question, question C, which is very, very important and highly examinable. Hii swali inakuanga highly examinable. Name the substance that is responsible for hardening of teeth. Meno yako itakuwa ngumu kwa nini? Ama itaweza kuwa ngumu kwa nini ndio iweze kuchew hard food? Of course, it will be strengthened by using calcium phosphate and calcium carbonate. So kwa mtihani ukisema calcium peke yake, it might not give you the full mark. So we say calcium carbonate and calcium phosphate. Any of that is going to make your teeth very strong and they'll be able to chew any type of food. And that is how you're supposed to have answered questions in that area. Now, so far we have talked about herbivores. Na tukamalizana tukasema, if you want to know a herbivore, look for 2 things. Look for a diastema and look for a honey pad. Na honey pad inaonyeshwa na kupata huyo mnyama hayuko na incisors on the upper jaw. And then the diastema unapata kwa mnyama ndani ya mdomo katikati ya canine na the molar and the premolar, utapata hapo kuko na space or kuna gap yenye inaitwa the diastema. Tumesema diastema inasaidia chakula kuturn in the stomach and not in the stomach, in the mouth, where freshly cut grass is going to be to await the chewing of the grass that is being chewed in the, of course, in the mouth. Very good. That is herbivores or herbivorous animals. Let us talk about omnivore dentation. Dentation of omnivores. What are omnivores? Remember tumesema omnivores are animals which feed on both vegetation and flesh. E.g., we have pigs and we have men. So any organism that is going to feed on both vegetation and flesh, it is neither a herbivore, neither is it a carnivore. So where is it? Iko hapo katikati. So the dental formula of an omnivore. So of course we have incisors. We have 2 incisors on the upper jaw and we have 2 incisors on the lower jaw. Hiyo ni yako yenye uko nayo, you can compare. Remember tumesema every time we are discussing the dental formula, tunaangalianga nusu ya jaws. So kama umeamua kuenda towards the left, unaenda towards the left. Kama umeamua kuenda towards the right, unaenda towards the right. So long as ulianza katikati ya mdomo hapo kuko na mpua, kwa mapua ndio usiweze kukosea. So incisors we have 2 on the upper jaw and we have 2 on the lower jaw. Then we have canines on the upper jaw ni moja and canines on the lower jaw. Then we have 2 molars on the upper jaw and 2 molars on the 3 molars on the upper jaw and 3 molars on the lower jaw. Zote ukihesabu vizuri alafu you multiply by 2 kwa sababu utakuwa unahesabu one side of the jaw. Of course you're going to find a total of 32 teeth. So ukipata meno ni 32, that's a strong suggestion that an organism is an omnivore. Adaptations of omnivores to dentation. How are they adapted to perform ama to feed on both flesh and vegetation? Adaptation number 1, the incisors are flat and chisel shaped for cutting and biting food. So utapata the incisors are well sharp to cut and bite food. Then we have the canines are small and pointed for tearing of food or flesh. So an animal can tear food using its canines. So they are small and they are sharp pointed. Then we have number 3, adaptation number 3 of omnivores. Omnivores, premolars and molars have cusps which are used for grinding, crushing and chewing. So unapata molars na premolars ziko kubwa kushinda incisors na of course canines kwa sababu molars and premolars chew the food. So when the animal is feeding on grass, that grass will be chewed using the molars and the premolars. Now, we have two sets of teeth in omnivorous animals. Remember, omnivores are the animals that feed on both that feed on both flesh and vegetables. Omnivore is an organism. So omnivore is an organism. Omnivorous is actually the mode of nutrition. So the sets of teeth in omnivores or in humans, we have milk teeth. So these ones are the first set of teeth and they are 20 in number. Ukipata na mtoto wa miaka kama 2 hivi ama miaka 3 utapata that child has around 20 teeth, lakini ukihesabu yako utapata yako iko around 32. So and then milk teeth is usually shed. Hii ni ile meno yenye mtu huwa anang'oa ama inajing'oa yenyewe from the age of 6 to the age of around hapo 12. Hapo ndio all the milk teeth gets shed and then the animal continues with the growth and development of the permanent teeth. Now, what is the difference between the permanent teeth and milk teeth? Milk teeth, once plucked out, it can regrow, but it will regrow as the permanent teeth. And like when it comes to milk teeth, then you'll find that the animal is going to lose them at some point. Okay, yes, so milk teeth, they are the first set which are lost between 6 and 12, and then of course you have permanent teeth. These ones are the ones that replace the milk teeth when the animal has lost the milk teeth, and of course they are around 28 in number, but with time they keep on getting increasing because we're going to have different animals different omnivores at different age are having different molars. So molar kama ilianza ikiwa 2 inakuwa 3, so that will lead to an increase. So eventually an adult, a mature human being, has a total of what we call 32 teeth. And then finally we have the last set of teeth, which is the wisdom teeth, and actually they are just molars. Okay, ni molars lakini zinabaptiziwa, zinapewa fancy name which is the wisdom teeth. Ndio maana tukichora dental formula hapa hatujasema ati incisors ni 2 on the upper jaw and 2 on the lower jaw, alafu canines 1 on the upper jaw and 1 on the lower jaw, alafu premolars 2 on the upper jaw and 2 on the lower side, na sasa kuna molars yenye ni 3 on the upper jaw and 3 on the lower side. The reason why we have not mentioned wisdom teeth in the dental formula there ni kwa sababu wisdom teeth is counted as a molar. So therefore when you'll be counting the number of molars, we count even the wisdom teeth, hence we come up with 32 teeth in number. That is omnivore's dentation. So if you look at that, basically it is your dental formula as a human being. Utaangalia uone kuko na molars, kuko na premolars, alafu utaangalia uone kuko na canines. I don't know if you can see the canines. Canines are usually very sharp. And then of course we have the incisors, which are on the upper jaw. So tukihesabu dental formula ya this, for example, I want you to look at diagram 2, the second diagram. When you're counting the dental formula, tulisema we divide the lower jaw or the upper jaw into 2. We divide it into 2. So tutakuwa na hapo katikati ya incisors tunaweka line. So we'll be considering this side of the jaw. Ndio maana unaona tunasema 2 on the upper jaw, 2 on the lower jaw. Kwa nini? Kwa sababu when counting the dental formula we consider half of the jaw, and the other half you will multiply by 2 because they are identical and they are equal. Okay, so that is basically the dental formula of an omnivore, and actually the functions of the different types of teeth in omnivores. So that one is not as much complicated because we are omnivores and we can always use that to our advantage while we are doing an exam. Good. From there, other than the omnivores, we have another very interesting mode of nutrition, which is carnivorous dentation. So the animal is called a carnivore. The mode of nutrition is carnivorous. Okay, the mode of nutrition is carnivorous, but then we have the organism which is a carnivore. Examples of carnivorous include cheetah, cat, we have dogs, we have lions. Those are examples of carnivorous organisms. Very good. Dental formula of carnivores. We have 3 incisors on the upper jaw. We have 1 canine on the upper jaw, and we have 4 premolars on the upper jaw and 2 molars on the upper jaw. On the lower jaw, we have 3 incisors, then we have 1 canine, and then we have 4 premolars, and we have 3 molars. So when you count that and multiply by 2, because you said we consider half the jaw, then of course that is going to make it a total of 42. A total of 42, and we have a total of 42. Of course, that is good number for chewing, tearing, and even cutting flesh. Adaptations of carnivores or carnivorous mode of nutrition. Adaptations of carnivores, and this is organisms which are in carnivorous mode of dentation. The first adaptation is that the incisors are chisel shaped and they are closely fitted to hold prey. So an animal can be able to grasp on prey using the teeth, because then we've said that the incisors are chisel shaped and small and closely fitted to size hold the prey during hunting or feeding. Now, what's a prey? A prey is that animal which is being fed on or which is being hunted by the carnivores. So in this case, if a prey is the hare, of course the carnivore is going to become the predator. The other adaptation of carnivorous organisms is that the canines are long, curved, and sharp. This so that they can be able to hold and kill and tear the prey. I'm sure if you have ever come across maybe a crocodile, or maybe you've come across a dog, you'll notice canines za hawa wanyama zinakuanga long and sharp. The reason why they are very long and sharp is because this animal is expected to hunt. This animal is feeding on flesh, nyama. How else will it cut the flesh or tear it if it is not through using the canines? So unapata the canines are used for that function. In other organisms, you'll find that the molar, okay? So utapata molar ya kwanza hapa imekuwa modified into a carnassial teeth. Like for example, let me show you carnivorous mode of nutrition. This one here. Ukiangalia hii carnivorous mode of nutrition, leave the first one, hiyo ni ya herbivores, eh? So let's look at the carnivorous. Carnivorous ni hii yenye naonyesha hapa. Let me show you. This is the carnivorous, hiyo yenye nimeshade blue. Ukiangalia vizuri utaona kwa carnivorous, we have the canines, okay? Look at the canines and see how long and curved they are. Look at how curved they are. On a canines, they are very long, they are very strong and curved. This is so that they can be able to tear through flesh. Then ukiangalia incisors, they of course they are wedge shaped and they are not as long and curved as the canines. Alafu utapata kuna premolars. How many premolars? 1, 2, 3. Kuna premolars ziko hapo. Alafu pale nyuma penye kuko na molars, kuko na meno inaitwa carnassial teeth. Now instead of the animal having molars za kawaida, one of the molars, one on the upper jaw and the other one on the lower jaw, gets modified into carnassial teeth. Kazi ya carnassial teeth inakuanga ya kuslice flesh. Ndio maana kama ni dogi akikula, unaonanga anakulanga ni kama anakula na side. The reason why anakula nyama ni kama anakula na side ni kwa sababu kuna hii carnassial tooth yenye inatumika ku crush bones, na ndio maana unaona dogi ama those carnivores, they can be able to crack bones. Unashanga amevunja hadi mfupa, ni kwa sababu they have a carnassial teeth which are very strong and are used to slice flesh, and they are also used to crush bones to get the bone marrow. Then we have the other diagram here, which is the dental formula of a herbivorous organism. Okay, so kuna hii dentation ya herbivorous organism. I want us to look at the horny pad. I want you to look at the horny pad. Remember tulisema in herbivores we do not have incisors or canines on the upper jaw. Instead we have a horny pad, na tumesema hiyo horny pad inakuanga ya ng'ombe kushikiliwa, kushikilia nyasi ama sheep ama goat while they are feeding. Now don't worry, when we'll be doing the practical activity, I'll make sure I show you the horny pad, and also I'm going to show you the diastema, so don't worry so much about it. I'll make sure that I show you that dental formula of herbivore. Of course, yeah, omnivore we have, and then of course, if possible, I'll also show you the dental formula of a carnivore. Good. So I hope you can see the horny pad, and also you can see the diastema, and then we have the molars and the premolars. Those ones are the parts of the dental formula of a herbivore. Very good. Structure of a tooth. Now, have we understood the structures, the dentations of carnivores, omnivores, and herbivores? Tumeielewa? Can we be able to tell the different types of animals based on the dental formula or the dentation when you've drawn for in an exam in form of a photograph? Hello, Monica, Domitila, are you there?
Yes, teacher.
Hasa ukiweza chorewa mkupiwe picha, kwa sababu kwa paper 3 usually unapatanga wamepiga picha ama wamekuchorea wakakuwekea hapo, so you should be able to tell the difference, eh?
Okay.
Yeah, good, but don't worry, I'll also show you in real life. Nitawapea a jaw of a herbivore and a jaw of a carnivore, alafu tuone wakati wa practical so that we can see the differences. So you can note that ndio next time when you have a practical, I'll be able to show you that and it will at least stick, eh?
Yes.
Good. Now the last thing that I want us to talk about today is the structure of a tooth. Meno inakaa aje, both internally and externally. Now remember tulisema meno inafanywa ikuwe strong na calcium phosphate ama calcium carbonate. Hiyo calcium carbonate inakuanga deposited kwa part inaitwa nini? Inaitwa crown. Now what's a crown? The crown is the part that projects above the gum. Wakati una smile, hiyo part ya white yenye inaonekananga ukismile, ama hiyo part ya meno inaonekana ukismile, ndio inaitwa nini? Inaitwa crown. Okay? Now we have the crown. So it is covered by a hard and white substance known as the enamel. So hiyo part yenye unaona hapo ni enamel na ni part of the crown. Sawa sawa? Good. Now of course tumesema the enamel is hardened by the calcium carbonate or calcium phosphate, a very examinable area. Wanakuambianga name the structure ama name the material that strengthens the crown or the enamel. Unapata mwanafunzi amekimbililia kuandika calcium. Ukiandika calcium peke yake hautapata. The reason why utapata calcium peke yake ni kwa sababu sio calcium peke yake huwa inafanya hii meno inakuwa strong, ama hii enamel inakuwa strong. Hii enamel inakuwa strong kwa sababu iko na calcium phosphate or calcium carbonate. So in an exam ukipeana calcium hautapata, but ukisema ni calcium carbonate or calcium phosphate utapata the maximum points, and then of course you're going to do well in that exam. Good. Haya, now roles of the enamel. Hii part yenye tumesema hii inaonekana ya crown, hii part inaitwa imestrengtheniwa na enamel yenye tunaona kazi yake ni gani? Number one, it protects the inner structures of the tooth from injuries. So hata ukigongwa meno, not unless hiyo meno imegongwa vibaya ikapasuka, you will not get to the internal part of a tooth. Now the reason why ukikuwa una meno inauma huwe unaumwa na meno ni kwa sababu hiyo part yenye tunaita crown, hiyo yenye imetengenezwa na enamel, inakuanga imechimbuka yote inaisha. So the internal part of the tooth is usually in contact with the environment. Ndio maana ukikula kitu moto iingie kwa meno yenye imechimbuka unahisi uchungu. Ukikunywa kitu baridi unahisi uchungu, kwa sababu ndani ya meno kuko na sensitive parts which of course are going to control how much pain you feel and how much pressure you feel. So therefore the enamel is very important because it prevents the internal structures from mechanical or physical injury. Good. Higher, the other adaptation of the enamel is that it provides a hard surface for biting and grinding of food. The reason why you're able to crush githeri, the reason why you're able to crush some nuts, the reason why you're able to use your teeth to crush hard substances is because it has a hard substance which is made of calcium phosphate or calcium carbonate that makes it very hard for the teeth to be able to crush the food. Okay, then we have the neck. I want to show you the neck of a tooth. Ndio hiyo sasa. Hapa kwa neck kuko na penye sasa enamel inaishia crown na penye your roots begin. So in every tooth kuko na roots na kuko na enamel. Hapa penye root inaenda kushikana na enamel ama crown is what we call the neck. Okay, so what is the function of the neck? It is the part between the crown and the root, and it is covered by gum. So ile part yenye inashikana na gum is what we call the neck. Then we have the root. The root is part of the tooth that is firmly fixed onto the jaw by cement. Ukiangalia hizo diagrams, all those three parts are there. You can see the crown which is made of enamel. Then we have the neck. And then of course we have the root, and the number of roots depends on the type of tooth. So if the tooth is an incisor, 1 root. If it is a canine, 2 roots. If it's a molar, 3 roots. And if it is a premolar, it will have 2. It will have to reserve the external structure of the tooth. Then we have the internal structure of a tooth. Internal structure of a tooth. Now this is how the internal structure of a tooth looks like. Of course, ukiambiwa internal structure of a tooth, tuna assume hiyo meno ilikatanishwa mara mbili ndio uweze kusoma. Now it doesn't matter whether it is an incisor, whether it is a canine, whether it is a molar or a premolar, the internal structure of a tooth is the same. The only difference is the size. Now when you look at the structure of a tooth, the outermost part of that particular teeth is the enamel. Na tumesema enamel ni juu, it is made up of a very hard substance yenye inaitwa calcium phosphate ama calcium carbonate. Then next to it we have the dentine. Okay, hope you can see the dentine. Then we have the pulp cavity. Hope you can see the pulp cavity. Now the function of the pulp cavity is simple. Hapo kwa pulp cavity kuna vitu mbili. Kuko na blood vessels na kuko na nerve fiber or the nerve ending. Blood vessel kazi yake ni gani? Very simple. Kazi ya blood vessel ni kusupply oxygen and nutrients to the tooth. It supplies oxygen and nutrient to the tooth. That is why the tooth is part of a living thing. Tooth ni living, especially when it is connected to the jaw, because it has a supply of blood capillaries, so oxygen inafika huko, nutrients zinafika huko, and at the same time we have the nerve fiber. Now the nerve fiber or the nerve ending, its function is to detect changes in the temperature or in pressure. Ndio maana saa zingine when you have a decayed tooth or a tooth which has had some dental caries or cracks, utapata because the cracks are going to allow some material to seep all the way to the pulp cavity, utapata sasa utaanza kuhisi uchungu. Kwa nini? Kwa sababu hii pulp cavity iko na nerve fiber which will detect that pressure or that cold which you have consumed. Okay, then we have the blood capillaries. Hizi blood capillaries tumesema they supply oxygen and nutrients to the tooth, and then of course we are going to have cement. And now the cement is the part of the tooth that supports your tooth, yenye inaishikilia ndio isitingike. So unapata ukitingisha ngano yako, the reason haitingiki ni kwa sababu imeshikiliwa na structure known as cement. So in an exam, usually they draw for you this structure, the first one or the second one, but in that setup hawatakuwa wamekujazia, we mwenyewe ndio unafaa kujijazia. Now we are supposed to know the different parts of the tooth. So the outermost is the enamel, the second one is the dentin, then we have the pulp cavity, and we have the nerve fiber or cement, not cement, and blood capillaries which are found inside the pulp cavity. Alafu meno inakuanga imeshikiliwa kwa jaw vizuri sitingike na cement. So if in case they draw for you in an exam such kind of a question, you should be able to answer that question very easily. Very good. Higher. So that is the internal structure of the tooth. Dental diseases, very simple. Now we have two dental diseases. There are only two types of dental diseases. Number one, we have dental caries or tooth decay. Hii ni yenye unapata meno inachimbuka. Ikichimbuka unapata unaanza kuhisi uchungu kwa sababu ina expose the pulp cavity. So dental caries is caused by plaque. Now plaque is a mixture of sugar, starch and microorganisms which accumulates between the tooth. So unapata ukikula skari, hiyo skari inabaki ndani ya meno ama imeguza meno. Sasa hiyo meno itaanza kuchimbuka polepole kwa sababu hiyo skari. Actually, the highest content of plaque is sugars. Okay, so sugars, and when sugars come into contact with your enamel, they are going to wear it pole, and then eventually what is going to happen is that you're going to have dental caries. Okay, yes, very good. So then we have the second type of dental disease, and this is the more complex one. Although difficult, it's just a bit complicated. It's the periodontal diseases. Periodontal diseases. Now, periodontal diseases are basically those diseases which affect the gum. So periodontal diseases are diseases which affect the gum. So unapata ni ugonjwa yenye ina affect gum. Now we have two types of periodontal diseases, that is gingivitis and pyorrhea. The types of periodontal diseases is gingivitis and it is gingivitis as pyorrhea. So gingivitis ni nini? Characteristics za gingivitis ni nini? Characteristics za gingivitis ni reddening of the gums. Unapata gums ya mtu inakaa red, alafu ana bleeding of the gum and presence of pus in the gums. So unapata the bleeding does not stop. Unapata meno ni kama inatoa damu huku kwa gum, alafu unapata the gum becomes red, and then finally you're going to find that in some cases persons with gingivitis will have pus on the gums. So it is very easy for you to note someone who has gingivitis. Then the second periodontal disease is pyorrhea. The second periodontal disease is pyorrhea. So in a condition where the teeth become loose, This is the condition where the teeth becomes loose due to infection, and the teeth are finally lost. So most of the cases unapata watu wenye wako na braces, kama si ya kulainisha meno, inakuanga because they have pyorrhea. Kwa sababu the teeth have loosened, the cement has loosened, so then we say this person has pyorrhea. Now, so that is pyorrhea. So in an exam, you get a question asking you, list 2 types of periodontal diseases. You'll say gingivitis and pyorrhea. Ukiambiwa step ama ukiambiwa state are 2 diseases, 2 types of diseases, dental diseases. Hapa hakuna kuchambua atuseme gingivitis na pyorrhea. Unafaa kupeana periodontal diseases na upeane dental caries. So I repeat, kuna maswali mbili unaweza ulizwa hapa. Unaweza ambiwa state 2 periodontal diseases. Ukiambiwa you state 2 periodontal diseases, hauwezi peana dental caries, utapeana pyorrhea and gingivitis. But ukiambiwa name 2 dental diseases, haujaambiwa whether ni periodontal. So ukiambiwa name 2 dental diseases, unafaa kusema dental caries na periodontal diseases. Those ones are the 2 types of dental diseases. Alafu ukiambiwa types of periodontal diseases, unafaa kupeana the gingivitis and pyorrhea. Now the most important thing then here ni spelling. Unaona spelling ya gingivitis na pyorrhea? It is very, very important that you get that. You get that spelling. Then finally, the last thing, control of periodontal diseases. How do you control dental diseases, or which are the health practices, which are the healthy practices that you can observe to minimize dental diseases? Number 1, we have regular brushing. So this is straightforward. Of course, you clean the teeth after every meal if possible, and if not, at least twice a day, before you go to sleep and in the morning, probably after a meal. Okay, that's the best healthy practice to carry out so that you can minimize dental diseases. The other one is avoid too much sugary food. Why are we avoiding too much sugary food? Because too much sugary food iko na nini? Iko na ability ya cause plaque. Na tulisema plaque ikiform on teeth, it is going to cause the teeth to start decomposing, and of course it is going to cause what we call dental caries. So avoid too much sugary food, and if you consume too much sugary food, make sure you brush your teeth immediately after you have taken that too much sugary food. Then we have eating hard foods. If you want to maintain a good dental hygiene, make sure you eat hard foods such as raw carrots, cassava, yams, and sugarcane. This is going to help to exercise the teeth and to remove the soft materials from the gums and the teeth. So, if possible, make sure you eat hard foods. And then, of course, taking diets rich in vitamin A, C, and D. Taking diets which is rich in calcium, phosphate, and vitamin A, C, and D. So this one is going to actually cause your teeth to strengthen more and to be more stronger. So the other hygiene or healthy practice which you can carry out to maintain and take care of your teeth so that they don't suffer from dental diseases is you should only use your teeth for the right purpose, which is chewing. Usitumie meno yako kufungua chupa ya soda, ati unaenda kwa sherehe juu hakuna opener, wanashinda akisema patilishie yule anifungulie, wewe tu unaweka tu kwa mdomo unafungua. The danger in that is when you are using your teeth to open the bottles, the teeth actually might crack. And when the teeth cracks, that will be the entry point to bacteria, which might actually even cause your teeth to actually break down all of it, or it is going to cause your teeth to have dental caries. So therefore you should only use your teeth for the right purpose. And then finally, after every once in a while, after 6 months probably, regular dental checkup. Let your dentist check your teeth and see if your teeth require some maybe cleaning, or if they are getting some cavity, which you can actually be able to solve in the early stages. So those are some of the healthy practices which you can do to minimize dental diseases at home. So that is it on the structure of tooth. And then of course we have the external and the internal, and the diseases of the dental formula. So that is it. So any question on that? That was like straightforward kwa sababu ni kazi I'm sure you had done before, na si kitu complicated. Hiyo ilikuwa kitu rahisi rahisi, so that's why we have rushed through. So have you understood the Domitila? Have you understood about the types of teeth, the structure and function of the teeth, and how to take care of our teeth? Domitila, umeelewa? Kama Domitila yupo. Monica, have you understood? Domitila, go ahead.
Niko lakini mali niko sisikii vizuri juu ya mvua.
Oh, pole, but at least you're following, yeah? Monica, have you understood about the teeth, the structure and types of teeth, and how they can be taken care of?
Yes, teacher.
So that means we can do some questions later about the teeth and the structure of the teeth to enhance our learning. Sindio? Good. So what you're going to do tomorrow, I will look for questions on the structure of teeth and the dental formula, and then we do them before we begin the lesson. Now we are getting into the most interesting bit, which is the digestive system of a man. So only very interesting, but we'll discuss it later. Okay? So for now, we have gotten what I wanted us to do. That is the structure of the tooth, how the tooth can be Domintila, kindly mute the mic.
Okay.
Thank you. So as I was saying, as I was saying, we have been able to talk about the teeth and the structure of the teeth, and of course we've been able to talk about how we can take care of our teeth, and we have looked at the internal external structure and the dental formula also of different animals. Then when we meet next, we're going to do several questions about that particular subtopic which we've covered today, and then we will jump right into the digestive system of a mammal. That is the most interesting bit about nutrition. Like you get to understand how digestion takes place, where different types of food are digested, which enzymes digest those food substances, and so on. So I'm not going to say much. I'll let it because tomorrow we will have a lesson in the evening. We're going to discuss that concept. So is there any question before we end the lesson for today?
No question on my side.
Very good. So if there's no question, I think we have understood the lessons well, and we wait for the next one. So thank you for showing up. As obvious, your wonderful audience. So tomorrow, God willing, we are going to meet and move on into something even more interesting. So have yourselves a blessed night. Take care of yourselves, and see you tomorrow, God willing. Kwaherini.
Good night. Mwalimu, kwa heri.
Okay, good night. Okay, bye.